So in today's lesson, we're still looking at using integration to find areas. So to remind you what happened in the last lesson, let's just make sure we can do these two starter questions. So let's find the two shaded areas that I've given. Pause the video at this point and the answers will appear in a second once you've worked through them. And it's quite important you don't skip these starters because they are the basis for what we are going to be looking at later on in today's lesson. So here are the two solutions. Hopefully you are able to integrate your functions, put the upper and lower limit into them, and you should have got 27 over 2 units squared for the first one and 9 units squared for the second one. So far we've looked at finding the area bounded between a curve and the x-axis. What we're going to look at today is how would we find the area bounded by two curves. So what I want you to do here is I'm going to bring our two starter functions together. So I'm going to take my blue curve and my green curve and combine them on the same diagram. So hopefully you can see what's happening there as I combine these two curves. And then what I get left with is I get left with a red area, a red shaded area. And hopefully you can see that that would be given by the area that was under the blue curve minus the area that was under the green curve. As the two curves came together, this area I'm left with between them is the difference between the blue shaded area in the starter and the green shaded area. And then because we know the blue shaded area, we know the green shaded area, we can calculate what this new red shaded area, the area between the two curves would be. And we can see that that answer would be 9 over 2. So that was a fairly long-winded way to find the area between two curves, to find the area under one function, the area under a second function, and then subtract them. There is an alternative method, and basically it's almost the reverse of that. What we do is we subtract our two functions first, and then we integrate between the two limits for our new function. So that's kind of given in this note here. I'd like you to pause the video, copy this note up, and then we will look at using this technique on our starter question. Okay, so we're going to return to our starter question. Again, we're going to find this red area. From the starter, we already know that we should be getting an area of 9 over 2 units squared. In the starter, what we did was we found the area under the blue curve, area under the green curve, and we realised that this red area is the difference between those two. So we now have a quick rule for doing this, which was you've just copied a note up on it, and it's given by the top curve, which in our case is this blue curve. So it's going to be x squared minus 5x plus 10. That's my top curve. And what we can do from that is we take away the bottom curve. So that's this green one here. So we're going to take away from it 2x squared minus 10x plus 14. And that's going to give us a new function that we are going to integrate between our limits 1 and 4. So when we have a look at this new function, we're going to be doing x squared, take away 2x squared. So my first term is going to be negative x squared minus 5x minus negative 10x will give me plus 5x, and then 10 take away 14 gives me minus 4. So I've now got a completely new function here. The combination of the top function minus the bottom function has given me this new function, and that's what I'm going to go ahead and integrate and then evaluate between my two limits. So we go ahead and we do our integration. So we get negative x cubed over 3 for the first term. We get 5x squared over 2 for the second term. And the last term, I get 4x. And I'm now going to evaluate that between the upper and lower limits. So first things first, put the upper limit of 4 into this. So I get negative 4 cubed over 3 plus 5 lots of 4 squared over 2 minus 4 lots of 4, and then I'm going to put in my lower limit of 1, so I'm going to get negative 1 cubed over 3 plus 5 lots of 1 squared over 2 minus 4 lots of 1. And now I just need to go ahead and evaluate all of these terms. Just to speed up so the video is not such a big file, I'll just speed that up. Grab your calculators if you need to. What you should get for this first bracket here though is we should get 16 over 6. Because I've got thirds and halves, I had to go to 6 to do my working. And then the second bracket, just make sure you can get negative 11/6 for that term there. We then combine these two here, we end up with 27 over 6, but we'll notice that that fraction is going to simplify, can divide top and bottom by 3, and I end up with 9 over 2 units squared. And if you remember, that was the answer we knew we should have got, and we've just shown there that this sort of quick technique I've shown you in the note works for that example, and it works for others as well. So hopefully you're able to follow that example. Usually at this stage, sometimes common questions from pupils are, well, what happens if the area I'm trying to find between my two curves is under the x-axis? Am I going to get a negative answer? The answer is you don't. You will, using the technique I've just shown you, you will always get a positive answer to represent the area between your two curves. So you don't need to worry that the area lies below the x-axis. As long as you're doing the top curve, take away the bottom curve for the area you're trying to find. So you'll see my top curve minus my bottom curve. So I'd be taking this function minus that function, whatever they were. Likewise, what happens if some of the area is below the x-axis, some is above, some of it's to the left of the y-axis, some of it's to the right? Doesn't matter at all. Just between the 2 points where the curves intersect, you would find the area, top curve minus the bottom curve to get your new function, and then integrate that between our two limits. So the questions for today's exercise, I think by the time you've dissected the video, copied up the note, watched the example maybe a couple of times to get your head around what's going on, then I think these 4 questions will be enough as an introduction, and then next week we'll spend a bit longer on the exercise. I'll come back with another video looking at a slightly more complex example. So the questions I want you to do today, page 361 and 362, it's exercise 17b, and just do the 4 questions in question 1. So just do A, B, C and D, and that should have filled your hour, and then you can stop there and we'll pick this exercise up, as I say, next week again.